Imagine for a second that you have just been hired to operate a really complex, incredibly dangerous piece of industrial machinery.
Oh, yeah. High stakes.
Right. We are talking about something on an offshore oil rig or, deep inside a copper mine. Or maybe a high-tech manufacturing floor.
Where, frankly, one wrong turn of a valve could shut down production for a week.
Exactly. Or worse, cause a major safety incident. Now, traditionally, your introduction to this mechanical beast would involve, like, shadowing a veteran worker for months.
Just hoping they remember to tell you all the little quirks of the machine.
Yeah, while you're simultaneously trying to memorize this dense, text-heavy engineering manual. But instead of all that, imagine this scenario. Someone walks up to the machine, snaps a few photos on their smartphone, grabs the standard operating procedure document, and feeds both of those into an app.
You just go grab a cup of coffee.
Right, because half an hour later, you put on a headset and you are standing in front of a fully functional, physics-accurate, 3D holographic simulator of that exact machine.
It's wild. You can pull the levers, turn the valves, practice the emergency shutdown until it's just pure muscle memory.
Which sounds, like the kind of bespoke $1 million training program that takes an IT department a year and a half to build.
Oh, at least. But the timeline from a photograph to a fully functional simulator has completely collapsed here. We are now talking about deploying enterprise-grade spatial computing on your lunch break.
And that is exactly the shift we are exploring today. Today's deep dive is based on a press release from June 10th, 2026. It announces a platform called Genesis 3.1.
Developed by EON AI Ventures, right?
Exactly. So our mission today is to figure out the actual mechanics behind how Genesis 3.1 is pulling off this magic trick. Turning static photographs and standard operating procedures into interactive industrial simulations in a matter of minutes.
And more importantly, why this is a massive tectonic shift for heavy industry.
Yeah, especially regarding how they're going to solve this impending, frankly terrifying brain drain crisis. Okay, let's unpack this.
I think the best place to start is just the sheer speed of what's happening here. Like when we talk about authoring a simulation.
Meaning the act of digitally building a 3D model of a real-world object that you could actually interact with.
Right. Genesis 3.1 has introduced an 8-time speed increase for that process.
Because the press release notes that building a working model previously took somewhere between 3 to 4 hours, which honestly already sounded pretty fast to me.
Yeah, for a complete 3D environment, it was.
Yeah.
But what's fascinating here is they have brought that authoring time down to under 30 minutes for a basic model.
Which is just, if you are listening to this and thinking, my company's IT department takes 3 weeks just to approve a software license.
Right. How are they building entire XR simulators in 30 minutes?
Exactly. That leap in efficiency is the whole ballgame.
It really is. It completely changes the utility of the technology because crossing that specific threshold from half a day to under 30 minutes takes this from a slow, bespoke IT project to a scalable, on-the-fly operational tool.
Oh, I see. So a floor manager could say, spot a recurring safety error during a morning shift.
Exactly. They capture the equipment, and they have a working simulator ready to retrain the crew by the afternoon shift change.
Wow. And the capture process itself relies on this new geometry capture feature. They are building these 3D models from ordinary photographs.
Right, and the source specifically highlights that these can be partial images. They don't even need a clean background.
Yeah, you can take a picture of a generator sitting in a messy, crowded mechanical room, and the AI can semantically extract the generator from the visual noise.
But the part that requires a deeper look is that the AI is actually inferring what sits behind and inside an object.
Which is kind of like, it's like a smart 3D photocopier that can guess what the back of your head looks like just from looking at your face.
That's a great way to put it. The inference capability is the real technological leap here. It's not just stitching together photogrammetry based on what the camera lens can actually see.
It's doing more than that.
Yeah, it's using artificial intelligence to understand the structural logic of the industrial component. And it computationally fills in the blanks where there is no visual data.
Right. It's a bit like procedural generation in a video game. The game doesn't store the geometry for every single leaf on a tree.
It follows algorithmic rules to generate the tree when you look at it.
Exactly. Here, the AI is procedurally generating the back of the machine based on its understanding of industrial design rules. But I have to push back on this a little bit.
Okay, go for it.
If we are talking about training people on safety-critical machinery, where a mistake literally means something explodes, how can a company rely on an AI that is procedurally generating, or let's be honest, guessing what's behind a high-pressure panel.
Right, because if a guess is wrong, that's a massive safety hazard.
Yeah. Hallucinations in a chatbot are annoying, but hallucinations in a safety simulator are dangerous.
And that is exactly where EON AI Ventures addresses this core hurdle. They do it by grounding the visual AI in factual text.
Okay, meaning what exactly?
Well, the system isn't just looking at the photos in a vacuum. It
Really?
is ingesting the company's existing standard operating procedures, the SOPs.
So it's cross-referencing the photos against the official engineering document.
Exactly.
But wait, how does an AI translate a written text document into a physical 3D space?
So it uses natural language processing to read and comprehend the SOP.
Okay.
When the AI reads a line that says, the primary pressure release valve is located on the lower rear quadrant of the housing, it translates that text into actual spatial coordinates.
Oh, wow.
Yeah. And then the system maps a standard verified 3D asset of pressure valve onto the unseen geometric mesh of the generator at those exact coordinates.
That is wild. It is literally turning written words into physical dimensions to constrain its own visual inference.
Right, verify it, yes.
That makes perfect sense. It's using the rigid engineering data to anchor the procedural generation. So, okay, the AI has generated this structurally sound 3D model in 30 minutes. But a 3D model, even a perfectly accurate one, is ultimately just a digital statue. To be a true simulator, it actually needs to react.
And Genesis 3.1 bridges that gap by applying real-time, interactive, physics-based animation.
So it's not just static.
Exactly. The platform applies physical properties to the generated geometry.
Because the press release is very specific about this. If you turn a valve, it rotates with the correct resistance. Fans actually spin.
They even have physics engines simulating fluid dynamics, smoke, particles.
And they are delivering this across multiple modes from a single software build, right? You build it once in that 30-minute window, and then it runs on a desktop computer, a mobile phone, or in a fully immersive XR headset.
Extended reality, yeah. Which means the software must be dynamically scaling the graphical fidelity and the interaction methods depending on whatever hardware you're using.
That dynamic scaling seems crucial for actual frontline deployment.
Oh, it is, because an operator might review the procedure on an iPad while standing in the actual mechanical room, right?
Right.
While, say, a new hire back at headquarters is running the full spatial simulation in a high-end XR headset. But the core physics and procedural logic remain identical across all those devices.
And I imagine this feeds directly into the new training loop they introduced in this 3.1 release.
The show me, let me try, evaluate me loop.
Yeah, that one. So if I'm a worker putting on an XR headset, am I just watching a digital movie of a spinning fan? Or am I actually doing something? Because the show me phase sounds like a guided 3D walkthrough.
It is, yeah. In the show me phase, the system visually demonstrates the physics of the system reacting to correct inputs.
Okay, but the let me try phase implies the physics engine is tracking my inputs in real time.
Exactly. And the transition from passive observation to active practice is totally seamless. When it transitions to let me try, those visual guide rails just disappear.
So I'm on my own.
Yeah, the user has to physically reach out in the XR environment or manipulate the 3D space on their tablet and actually perform the procedure.
And if I turn the valve too fast, the simulation has to know the pressure spiked.
Right. The physics engine tracks the velocity and sequence of your inputs. If you induce a catastrophic failure in the simulation, you see the simulated consequences immediately.
Oh, wow. So you get to make the million-dollar mistake in a sandbox where nobody actually gets hurt?
Precisely. And then you have the evaluate me phase.
Which must be analyzing all that input data, right?
Yeah, the system assesses the worker's performance by checking their input logs against the spatial rules established by the SOP. It scores them on accuracy, safety compliance, and efficiency.
It's a complete pedagogical model.
It leans really heavily on the cognitive science of the enactment effect.
The enactment effect.
Yeah, it's the idea that motor skills and spatial memory are processed differently in the brain than just basic reading comprehension.
Oh, sure. You learn by doing.
Exactly. By forcing the user to physically enact the procedure, the technology is building genuine neurological pathways. It's actual physical competence.
So you're building this perfect digital muscle memory. But the irony here is, while companies are finally figuring out how to build digital muscle memory in a matter of minutes, their actual human muscle memory is walking out the door.
Which brings us to the whole macroeconomic crisis, driving the urgency of this June 2026 release.
Right. If the tech is this good at capturing tasks, why does it matter so much right now?
It all comes down to the aging workforce in heavy industry. EON AI Ventures actually coined a term for the specific asset they're trying to capture and preserve here. They call it work intelligence.
Work intelligence, okay.
Think about how general-purpose AI models are trained today. They scrape the public internet, right?
Yeah, they ingest Wikipedia, Reddit, open source code.
Exactly. But the specific, granular, hard-won procedural expertise of how a company actually operates its proprietary deep shaft copper mine or its custom manufacturing line, that does not exist on the internet.
No, of course not. A general AI chatbot doesn't know the trick to unsticking the number 4 valve on a specific offshore rig in the North Sea.
Right. The only place that operational knowledge exists is in the head of a technician who has worked on that exact rig for 35 years.
And that expertise is deeply siloed human capital.
It is. And across the industrial sector, that generation of highly experienced workers is retiring at just a staggering rate. When they leave, their intuitive heuristics and deep operational knowledge leave with them.
So the company experiences a massive capability drain, a brain drain.
Exactly.
There is a quote in the press release from Dan Lidgerskar, the founder and chairman of EON AI Ventures, that really highlights the timing of this. He says, Genesis 3.1 is the moment our industrial simulator becomes ready for business. We can now take a customer's procedures and a handful of photos and turn them into a working, hands-on pilot in a single session. Nobody else is doing this, and the need across heavy industry is enormous.
And that's why Genesis is positioned as the ultimate defense against that brain drain.
By capturing the knowledge before it leaves.
Right. By pairing this rapid simulator creation with EON's other software suites, specifically FieldIQ and SesIQ, these companies are fundamentally changing how they manage knowledge.
They are codifying an operator's intuitive heuristics into a quantifiable digital format.
Yes. Turning fleeting human experience into a proprietary, reusable corporate asset before the worker retires, and that knowledge walks out the door.
It makes a lot of sense, because as artificial intelligence automates more traditional desk jobs and software tasks, the unique, durable value of an industrial enterprise is no longer just the physical machinery they own.
It's the highly specialized proprietary knowledge of how to operate that machinery safely.
Exactly. And Genesis 3.1 acts as the capture mechanism for that work intelligence. But this brings up a practical reality check for me.
Okay, let's hear it.
Because the enterprise software market is famous for slick marketing videos that promise the moon but never actually deploy securely across a corporate network.
Oh, absolutely. Vaporware is everywhere.
Right. So is this platform actually out in the wild right now? Is it purely theoretical, or can people use it today?
It is entirely live.
Yeah.
Genesis 3.1 is available right now for EON Reality customers and partners.
Oh, wow. Okay.
Yeah, the release specifies that 6 out of their 12 target industry segments are currently active. Organizations can begin a pilot simply by providing those existing SOPs and reference photographs we discussed.
So it's real.
Very real. They have integrated live demonstrations directly into their EON Enterprise Hub infrastructure.
And they are also fairly transparent about the roadmap and what is still in development. Like, they note that full assembly and disassembly procedures are coming next.
Which is a huge deal.
Yeah, so not just turning a static valve, but actually moving physical parts through a 3D space and snapping them together in a complete mechanical sequence, which I would assume requires a totally different level of collision detection and physics tracking.
Oh, definitely. Tracking independent moving components through a sequence is a massive computational challenge.
Right.
But this is where the broader context of EON AI Ventures becomes really relevant. I mean, they are not a newly minted startup operating on theoretical venture capital.
No, they've been around.
They are building on a 25-year heritage of XR and artificial intelligence development.
And the press release highlights some staggering numbers to back that up. They have over 4,400 institutional customers across more than 80 countries.
And over 136 million platform downloads.
That is a massive established footprint.
And those numbers matter immensely for a production-ready rollout. Because building a neat virtual reality demo in a lab is one thing.
Right.
Deploying it securely across corporate firewalls to 80 different countries, that requires a massive, robust content delivery network and deep systems integration.
But they actually have the runway to execute this.
Exactly. When a company with 136 million downloads and a global infrastructure says they have reduced a simulation authoring process to 30 minutes, it means they actually have the server capacity and the pipeline to distribute that simulation to an iPad in a mine in Chile the exact moment it finishes compiling.
They have the logistical runway to make the 30-minute promise a reality on a global scale.
Yep.
Okay, so let's briefly recap the journey we've just been on. We started with the old paradigm, learning a dangerous machine by studying a dense manual and hoping for the
The
best.
terrifying prospect.
Truly. Then we looked at how Genesis 3.1 uses artificial intelligence to cross-reference ordinary photographs with standard operating procedures. We explored how it uses natural language processing to translate text into spatial geometry, inferring the hidden structures of industrial equipment to build a physics-accurate 3D simulator in under 30 minutes.
And we also examine how the software dynamically scales across desktop, mobile, and XR platforms to facilitate that show me, let me try, evaluate me learning loop,
Right, translating visual information into vital physical muscle memory.
which is so crucial.
And the overarching significance here is how this technology acts as a net to capture a company's work intelligence. It's digitizing the hard-won expertise of a retiring generation so that a company's operational capability never just walks out the door.
Yeah, exactly. But there is one last thing to consider here.
Oh, that's that.
We have seen how Genesis 3.1 uses AI to perfectly ingest procedures and simulate how a machine currently operates, right? All based on past human knowledge.
Right, relying on the SOPs.
But if this artificial intelligence now fully understands the hidden spatial geometry of these complex machines, and it can perfectly simulate the physics of how they function, it leaves us with a really fascinating proposition.
I'm listening.
How long until these simulators stop merely teaching humans the standard, accepted procedures and start independently simulating and suggesting entirely new, safer, or vastly more efficient ways to operate that human engineers never even considered?
Oh, wow. That is, yeah. I will let you sit with that one. Thank you so much for joining us on this deep dive. Hopefully the next time you have to learn a complex new system, it involves a spatial hologram and not a towering stack of technical documents. Keep learning, keep questioning, and we'll catch you next time.